Okay, so as you guys are kind of finishing that up, what this section is it's figuring out which of those models that we've been working on, so like linear, exponential, quadratic, that kind of thing, which of those types of models fits best with like a specific scatter plot. It can be kind of tricky sometimes. I was doing some of the problems on the worksheet and trying to set up your quiz and your tests and stuff, and it can be a little bit tricky to figure out which model's best. As long as you're doing your best and like you pick one that seems reasonable and you kind of show me how you went through and did it, I'll be understanding because it is kind of tricky and confusing to try to get it exactly matched up good. But there are ways to kind of predict which one would be the best model. So residuals, we've been talking about residuals, right? So it's basically like calculating your error or how well your model, whatever equation you come up with, actually fits to your scatter plot. And then for our residual, it's always our observed minus our predicted. And then what they do is they actually introduce something called residual plots, which is kind of like a scatter plot, but with your residuals instead of just like your ordered pairs. So like if this was just our regression model here, we had this scatter plot, we came up with that line to kind of fit with that scatter plot. What we do for this residual plot here is basically you would take, your point here, so like 9 and then whatever it is, you would figure out how far that is away from the line there, and then whatever number you get, that's now your y coordinate when you do your residual plot. So your x's still correspond with each other, but then your residual tells you how far it is from the line. So you can kind of see here that that point was the furthest from the line, and then looking at the residuals, that makes sense that it's furthest from the line there because it was farthest away. And then things on the top are positive, things on the bottom are negative, and then the rest of those points fit pretty well there because they're pretty close to that line. And then those other 3 pictures there, they just give you 3 examples of good versus bad ones. So a really good one is where all of your points are like really, really close to that x-axis, because that means that they're just like not very far away. And it's also helpful to have like half of them on the top and half of them on the bottom. That means half of them are on like the upper end of being off, and then the other half are on the lower end. This wouldn't be a good setup here because there's like one small cluster that's pretty small for residuals, but like there's a ton over here that are far away and a ton over there that are far away. And it also appears that all of them are on the upper end of that and none of them are on the lower end of the residuals. So that's probably not a good setup. And then this one's not great either because it fits really well at the end, but at the beginning, obviously, it's not fitting very well. Like I said, sometimes when we get actual real data, it's kind of hard to get one that's like super, super good like this. But as long as you're trying your best and kind of showing me the steps, I'm not going to get too wound up about it. Like on the test when I was making the answer key the other day, I actually did it for like all 3 things out, so I could like, okay, if they did this one, then the residual plot looks like this. If they did this one, it looks like this. One of them's way better than the other 2, but I did kind of do it out so I can at least give you some points for like doing the process out, if that makes sense. Okay, so let's try one of these. So we'll go to our example sheet there, and it's the activity instead of an example, but it's the same thing. Go to that, and then the directions are just in the book with the activity, and that's on page 134. So it gives us some information here, and the first thing it wants us to do is it says it wants us to use a statistical utility to create a scatter plot of U.S. Census data shown at the right. Obviously, it's to the left there. And then use years after 1790 as the independent variable. So they just want us to basically make a scatter plot of this information on our calculators. Important thing to note here, it does tell us in the directions that it wants us to use the year after 1790 as our independent variable. So instead of typing years into our calculator, what we're going to need to do is we're going to need to change these all to like how many years it is after 1790. So like that first one there would just be 0 years, right? Because it's right on 1790. And then like 1800 would be 10 years away. Next one would be 20 years away. And I'm pretty sure, let me double check here. I'm pretty sure it just counts by tens as you go. So I would put those little numbers next to your year. So like 30, 40, and so on. That way you know which ones to type in your calculator. believe it goes up to 210. So just counting by tens there, but they want us to use those numbers instead. And they'll tell you in the directions which ones they want you to use. Okay, so then we're just going to type that information into our stat button or whatever. So I just go stat, edit, get your lists up there just like we've done lots of times. And then again, writing those numbers in there for the year as our X values. And again, don't use the actual year, use what we just figured out there. So like the 0, 10, and so on there. So get that typed in, I'll get it typed in too, and then we'll look at it. And then your Y's are just your populations there, so you just type those in. And if you want to, since this is the activity, it doesn't like write the questions out, but if you want to put like for step 1, we just graphed scatterplot on calculator. And then we can do a little sketch of it too once we get it graphed. But that way you know what we actually did for this activity. Okay. Everybody got her typed in? Okay, so then we would just do our normal scatter plot stuff. So we just go second stat plot, and then turn our plot on. And this time we'll want it as list 1 and list 2 because that's where we just typed it in. And then I would hit zoom, and then go down to zoom stat because we want it to zoom in on our statistics. So zoom, and then arrow down to zoom stat, which is the 9th one. Hit enter. And I had something in there for my y equals, I'm going to get rid of. Okay, and I get something that kind of looks like that. Okay, everybody following so far? Everybody get something like that? Okay, so like I said, if you want to kind of just sketch in, what it looked like, just so you've got, an example of why we chose the graph we chose. Okay, so now looking at our thing here, or our scatter plot there, we got to figure out which of those things we've talked about that this kind of matches best with. Let's start with linear. Does that appear to be like a straight line? Probably not, right? So I probably wouldn't even look at linear because it doesn't even seem like it's even close to that, okay? Exponential's our next one. What do we think about exponential? Does it seem like it's kind of starting slow and then going up quicker? Yeah, I would agree with that. The other one's quadratic. Oops. The other one's quadratic. I think the most confusing thing is picking between exponential and quadratic. Quadratic, though, is more like it would like curve up both ways. It doesn't have to, but like it's more like when it's the U shape versus just like that part. You can still fit quadratics to this, but exponential is probably more where you would want to lean, would be my guess, and we'll double check that with our residual plot. But I would lean towards exponential on this one. So then what I would do is I would actually calculate what my exponential one is. So I would go stat, calc, and then go to your exponential regression. Hit enter. Your guys is the new ones. Will ask you questions about it. Just make sure it's list 1, list 2. Mine just does it. Okay, and then we get our numbers there. So I would just write those in then. So, and this is for step 2. That was just us finding our thing. So I'm just going to put that we did exponential regression just so you remember. And then I got like y is equal to, I'm going to go to the thousands place with each of them. My a is like 6.033. And then my b is like 1.020, I guess. To the power of x. And then like one thing you can check here to see if it's decent, you remember we did like the correlation coefficient, like that R value. You want that to be either really close to 1 or really close to -1. So here like 0.98, that's not too far away from 1, right? That's pretty close. 0.99 would be a little bit better, but it's still pretty close there. The only thing that sucks here is like if I were to do quadrag, you don't have to do this, but if I do quadrag, it doesn't give me that R value to check against, so you can't really use that to like compare the two, and the R squared and R are different. So that's why it kind of sucks. You can't just use the R to check it. You got to use the residuals. Linreg though does have the R value. So like there, our R value when we did a straight line was 0.959. So obviously that's a little bit worse than it was when we did the exponential one, right? So that's another way you can kind of compare those two, but the quadrag doesn't have that. I'm not sure why. There's probably a specific reason, but it doesn't have it, so we got to kind of just use our other resources. Okay, so then for the third step, it wants us to use that exponential regression model that we just did to compute a spreadsheet like this here where we kind of figure out like our residuals and stuff, and then plot a residual plot. Okay, so what I would do is I would just, now I got all this other crap on here, I would just use my calculator to do this. So if I go stat edit, and then I go, remember when we typed in our residuals into that third one? Can't remember doing that. That's what I'm going to do. So I'm going to go stat edit, and then I'm going to arrow over to my L3, arrow up there, and then we want to go second, and then our stat button again where it's lists, and then we want to arrow down to residual, and hit enter, and then it should put residual in there for your L3. So I can do that again. So it was stat, edit, oops, arrow over to the L3, arrow up to where your L3 is highlighted, and then you go second, stat button for the list, down to residual, enter, and then it should show your residuals there. Okay, are you guys getting what I'm getting? Okay, because I was typing that other stuff in there, so I wasn't sure if that was the same numbers. Do you guys, like, for your first one there, have like 44.625 or something like that? Does anyone have anything different? For like the first one. Because I was just wondering if mine calculated different. Say it again, Weston.
For the residuals?
Yeah.
I should try it again. Yeah, mine's...
Yours is different? Because I was wondering if I typed that stuff in there, if it would mess it up.
I like got -2.
Okay, alright, that's what I was wondering. Since I typed in that other stuff there, I was wondering if it would get messed up.
I think I tried to like do this one time on one of my assignments and didn't work very well.
Okay. Well, we can calculate them by hand. You know, just calculate them by hand since this is fucking up. Probably shouldn't swear when I have it recording, but oh well. Okay, well let's just do it by hand then. Shouldn't have made my numbers go here. Okay, so if we're doing it by hand, we just need these columns, I think. Okay. Yeah, you're right, because it should be that first one. They've got -2.03. I'm wondering if when I typed in those other ones to check those, if it was calculating the residuals for those ones. You know what I mean? Since I typed in the quadrag and the linreg, that it was doing something different. But we'll just do it by hand. Okay, so how you would do it by hand is to figure out our predicted population here. That's where we would use that equation. Y is equal to 6.033 times that 1.020 to the power of x. And then you would just take, this is going to go into my words here. I should have prepared better. Oops, not that one. This one. Because that's where they have like our years after we subtracted. Those are like our x values. And these would be like our y values. So the next one would be like 30, 40, 50, 60 and so on there. Sorry, it's in my words. And I was just taking those from over here that they had listed out, so I went up to 210. Okay, and then our populations there, we don't have to write those if we don't want to, but those are the ones that are listed off to the side there. And then our predicted ones, what we're going to want to do is we're going to want to take these x values that we just wrote down, put them into our equation there, and there's a quick way to do that. We can just graph this line and then just use our table to come up with all these points, right? So what I would do is I would take this equation here that we've got written down, go to my y equals and type that in there. So 6.033 times 1.020 to the power of x. And you don't have to do it this way, you can do it by hand too, but this will save us some time. And then I'm going to change my table set. Since these are counting by tens, I'm going to change it to counting by tens. Do you guys know how to change the table set? You guys done that before? Okay, so yeah, so I'm going to change it to counting by tens, so it's like that little triangle table. I'm going to change that to tens. And then I'm going to change my table start to 0, so I just started my first coordinate there that I want. And then now if I go back to my table, it should count by tens there and give me my numbers out. So like the first one for my predicted population should be that 0 point, they just ended at 3, but those would be those numbers there. So they did the first ones for us, so 30 is the next one we need. So it's like 10.928, 13.321, 16.238, 19.794, 4.129, 29.414, 90 is 35.855, 43.707, 53.279, 64.946, 79.169, 96.507, 150 is 117.64. The one on the test will have way less points than this. It's got like 6 points, not 100. Okay, and then 160, 143.4, 174.81, 213.09, 259.76, 200 is 316.64. Of course, it'll shut off again. 210 is 385.98. We could have probably rounded on some of those, but I just wrote it as is. Okay, so follow me so far that we just took our x values, put them into that equation, kicked out what it should be based on that model. Okay, so then for our residuals, what they do is they take whatever was originally given to us, so our observed value, minus our predicted value, which is these numbers here, and that's what should be coming from that chart. I wish I had it on my thing that I wouldn't have to do it all out by hand. Weston, is yours still right here?
What?
Do you still have yours as the residuals that came out correctly?
Yeah, I might have.
Okay, can somebody give me theirs so I can just copy them?
Well, mine are a little bit different because like.
It rounds different.
Well, I did the alpha trace and I had like the exact equation.
Oh,
So
yeah,
it's come
yeah.
out a little bit different.
Okay,
years,
yeah.
so,
Which is fine.
um,
We'll just write them down. I got James's calculator, Weston.
oh, okay.
Yeah, I think I just messed mine up. So the first one here is negative 1.068, and then negative 0.55, 0.4125. 60 is 2.6938. And again, the numbers are going to be a little bit off because, James, you probably did the same thing where you put the y in for when you actually graphed it, like the actual y instead of the rounded one.
That's all on my stat plot. I didn't change any of it. That's the whole stat.
Okay. Well, we'll just keep writing it. As long as you guys know where the numbers are coming from, does everybody get that you're just subtracting the observed minus the predicted? Yes, no? Okay. I know this is kind of confusing.
The 2.033 number.
Yeah.
That's the first.
Yeah, that's what James's has too. James has that same thing. You can see it on there. It's because you use like the actual one in there. Yeah, you start at, yeah, because the first, yeah, the first ones are listed there already. So that's why. But yeah, it's basically just the original population minus these ones. Alright, now I got out of it. Okay, what were we at there? 90?
Yeah, those are the same ones that
Yeah. Which is gonna suck because I was gonna do the residual plot on the calculator, but now mine won't do that. James, I might just steal your calculator.
Okay.
Like I said, this one's kind of obnoxious. I wouldn't make you do this many on the test. And I'll scan this and put it on the website. So if you're missing some of these, you can get them later. Okay, well, that's those. Okay, so then now how it works with the residual plot is what you would do is, so step 3 is kind of doing that stuff out. So like step 4 is the actual residual plot. So all of our x's are the same. So like as you would go out here, you would go like 0, 10, 20, 30, 40, 50, all the way up to like 210, kind of going across. I'm just going to sketch the scatter plot or the residual plot instead of actually doing it. But basically our x values go out here. So like if you wanted to write it out, 10, 20, 30, whatever. And then up the side here, these are like your residuals, how far it's off. And you can use the calculator. Like I said, I'm going to steal James's here. You can use the calculator to come up with the residual plot. So what you would do, and maybe you want the steps here, you would go second, and then stat plot. And then this time when we plot, we want to do our list. So if you have the numbers in the list, like James and Weston had on theirs, if you don't, like just kind of follow along and we can figure that out later. But if you've got it in there, you can follow what I'm doing here. So if I go stat plot, and then this time change, keep my list 1 as, or my x1 as the list 1. Actually, have to turn your brightness down, James. There you go. It's a little better to read. Okay, so I'm going to change my list, or I'm going to leave my list 1 as, or my list, x list as L1, and then I'm going to change my Y1 instead of my values that we plugged in here. We want to change it to the residuals, so I'm going to change that one to my list 3. So I got to go, no, not that. I got to go to second, and then I should probably be on the right thing. Second, and then down here, if you go to the 3 button, hit that, that'll change it to list 3. So list 1 as the X, list 3 is the Y. And then if we go zoom, stat again to get it zoomed in on their stats, that would be what your residual looks like. So it looks like it's doing fairly decent for a while, but then it kind of starts getting off, and then towards the end it's like super off. And if you look at your numbers there, we're fairly close through here, but then kind of see how it gets up to like negative 54, negative 95, and then negative 141, and that goes off by a lot. That's kind of being replicated here. So it was really good for a while, kind of okay there, and then it kind of starts getting way off there. If it was just like 1 point that was off, it wouldn't be too bad, but as that's kind of going, it's not the best fit there. But I would just do a little sketch of that for like your residual plot. Something like that. Okay, and then it seems like it's a good plot for a while, but then as time goes on, it's probably not the best plot. So for step 5, it asks us to kind of like analyze that. So I'd say like exponential model is, let's just say, an okay fit. But as what is it? As years get let's go higher, I guess, or larger. As years get higher or larger, the model fits less well, or something like that. Not as well. Model fits not as well. Something like that. Okay. Let's end it here. I don't even know how much is left, but let's end it here and just keep talking about more of this stuff tomorrow, because I feel like we need to talk more about this stuff. So I'll stop this here.